Hey everyone, Blockchain Bernie here, my latest episode 346, and my apologies. We got confused with the numbering, so we just kind of reset back to the 200s, but it's already 346, so we're back in the schedule. And I'm giving you a sneak peek today into the new Xandeum Solana Validator Software. That is the core of the Xandeum storage layer that we're building. It's right here. So, and we will be launching that Devnet real soon. We have the draft DAO proposal already there. So it's going to go out into the DAO real soon. If you don't have XAND tokens, you can't vote in the DAO. So get your XAND tokens on Jupiter, jup.ag, buy the XAND token. So that way you can be part of our DAO if you already have your XAND tokens. And I guess most of the audience today here already has their XAND tokens, has deposited into the DAO. And I'm giving you a sneak peek now how this all works with the modified Solana Validator software. For that, I'll just give you an insight here into the validator. So you see it right here. So this is one of our development machines here, where we develop the validator here, right? So what you here see is the Xandeum Agave repository, and Agave stands for the new Solana Labs validator client, right? So it used to be all the Solana Labs, but they spun off that company called Anza off of Solana Labs. Don't ask me for the exact reasons. My, personal assumption is they did it because of the scrutiny from the SEC and things like that, and Sol potentially being considered as a security or stuff like that. But they might have had other reasons. I'm not sure. But yeah, fact of the matter is, it's Anza, and they don't call it the Solana Labs validator software anymore. They use the word client, right? So that's kind of in blockchain. The validator software is often just called a client for some reason. I think it all started in Ethereum with their several Ethereum clients that they have. And on the Solana blockchain, we are also in the process of having multiple clients, multiple implementations of the validator software. But the most common still today is the one that was originally developed by Solana Labs, and now it's called Agave, and it's being developed by Anza, that spin-off of Solana Labs. Okay, so we forked this repository, the Agave repository. It's on GitHub, and it's called Anza XYZ/Agave. So that is the current validator software that's being used on Solana mainnet now by 99.9% of the validators that are out there. We forked that and into our own repo, which at this point is, just for development purposes. It's a private repo, but it, probably will be open sourced real soon, so that you can see all that. But I have this repository checked out here on my development computer. You see all these different directories here, and the main changes that we are making here on that validator client is in the RPC module, right? So if someone wants to send a Xandeum-enabled transaction to the Xandeum network, right? To later on Solana mainnet, right? But for now, it's going to be Xandeum DevNet, right? We're building on that, right? Before the thing is actually ready and tested, we can't deploy it not on Solana testnet and also not on Solana mainnet. But we might be deploying to Solana testnet sooner than we think, right? Because Solana testnet is also permissionless. We could deploy anything we want. So we might do that quite early, maybe in, as early as springtime next year, deploy some early versions of our Xandeum validator software there onto the Solana testnet cluster. What we're doing here now is we have made changes to to the RPC module, right? So if I cd into the RPC directory, there's only that src for source directory in there. And there's a lot of files, right? And we made changes here to the RPC .rs file. RS is for Rust, right? The Agave client is all written in Rust, which is nice. You can't see much here now because, I made the font a little bit bigger so that you can see it when you watch this video or this live stream here. But you see where we've made changes here. We've commented that with actually start Xandeum, end Xandeum, things like that. So this is the send transaction here, right? So everyone that sends transaction to a Solana cluster has to use the send transaction function. So we see a lot of stuff here where things are being decoded. And then here is a block where we entered our stuff, right? So we're finding that sanitized transaction here. So a few lines earlier, this transaction is going to be sanitized, which means it's being unpacked into a JSON or a Rust struct that can actually be read here. And what we're doing here now in our code, this is all our code here. And we're calling a program called XAND Shield program. And it's called XAND Shield because, well, it's shielding normal validators that don't know about Xandeum of actually executing that code, right? So if someone sends that to an RPC node that doesn't know about Xandeum, it'll run into an error, and only the Xandeum-enabled RPC nodes will actually be able to handle that. And then if it's a Xandeum-enabled validator, then this code will be executed, right? And then we will look for a call for that XAND Shield program. And if we find that XAND Shield program, then we found an X instruction, right? So that's a Xandeum instruction that contains those peek and poke operations that actually handle that file system that we're building that's accessible to the Solana developers. Every time I get excited when I talk about that. And once we have that, we hand things off to what we call the doc, right? So we have a component there that says that is the doc, and in that doc, that's a separate process. It's not running inside the validator process. It is running in its own process as a sidecar on that same machine where the RPC node is running on. And that is also super exciting because we only make that little, surgical change here to the validator software that I just showed you. It'll hand that off to the doc, which is a process of its own. It'll communicate with the validators with some lightweight message queues. Maybe it's going to be shared memory. We're still figuring out what's the best way to do that. In any case, it's some IPC mechanism, right? Inter-process communication. And then that doc is running as a process of its own. And that helps, getting that adopted with people that run Solana RPC nodes, because they can see only that surgical change that we are making to the actual Agave client. It's that change that I just showed you. And then everything is handed off to that component that's called the doc that runs on those RPC-enabled validators, RPC and Xandeum-enabled validator nodes, right? So we are building that stuff, as you've seen. We already put that stuff in there. We've done our first steps with the actual doc software. We've done our first steps with the XAND miner software that has the actual GUI on it. And all that will go together, and we'll have some sort of early working prototype by the time that we add the PNodes to the Devnet, right? So right now, the Devnet will only start with those validator nodes, but you will already, so whoever's running nodes on the validator. And by the way, I see the live chat here. I'll just go to that. It's always the same guy, Fox Crypto Boss. Great, you're here. Let's go to this terminal window again here. If we leave the editor here and go back to that directory where we came from, and if we use the Solana program now, right? So we're building all that validator here from source code. And of course, we've optimized the machine for development here, so we can build the whole validator in 5 minutes with everything being recompiled, which is really, really important for the rapid prototyping that we're doing here to build that Solana validator, right? So if we say Solana-V here, uppercase V, which means give me the version of this Solana tool here right now, right? Then we see the normal Solana convention here, right? So it's not like it says the command in the old Xandeum network, the Xandeum Classic, we renamed that Solana tool to Xandeum and all that kind of stuff. Now we're 100% compatible with all the other Solana stuff so that we can get fully integrated. And that was so super important here. And the main reason on why we moved from that Xandeum Classic approach to this new approach. So it says Solana CLI stands for Command Line Interface, version 2.1.4. That's one of the latest releases that is being used out there on Solana testnet these days. And you see a few things here. And I start in the back here with this client thing, right? It says client Xandeum, right? So that means this is the Xandeum variety, the Xandeum flavor of that Agave validator. It means it includes modifications that Xandeum has made to this validator software. So by running that, anyone can see, well, this is not the plain Agave validator. It includes modifications made by Xandeum, right? But you will also see that it's, based off of the 2.1.4 version of the Solana CLI, right? And then you see the SRC here. That stands for source. So this is the source version of our modifications that's actually going in here. And those might be different, right? So we might have a Xandeum version of the Agave client based off of 2.1.4 with a different source version. And this is just the first 8 characters of the hash of that commit, of that git commit that we've done to our fork of the repo. So right now, this is the latest commit here, and it's not increasing, right? It's just some random numbers here. It doesn't mean if the number is higher, then it's a later release or something. But you can download these from our binary repository that we've used before also. So that's all great. And this is the feature set, and you can ignore that here because that's for, if we're on mainnet or testnet, the features are gated, right? So even though they are features compiled into the client software, they might not all be enabled. They are gated, and then whoever has the keys for these feature gates can enable these features while the cluster is live. But we don't do that on our development cluster, right? And we don't do it on our Devnet. So everything that's compiled into the software is enabled by default. There's no feature gating. So that's the reason you can ignore this feature thing here. But for the SRC, that's important, right? This version is important because we're moving with the Solana, the Agave releases, right? Because that is super important. We can't just use this 2.1.4 and then do our work on that forever. We need to rebase our work on each and every new release of the Agave validator that's coming out. So that's why we've taken this approach here. It's 2.1.4, and then we have that client version here, and we have that source version here, right? So yeah, those are the things that we're doing here, and and making our progress here. And yeah, that was a little bit of an update, because when this channel here, this Blockchain Bernie channel, is also about the making of Xandeum, right? So some of my videos are just about the making of Xandeum. Some of them are just general crypto education, blockchain education. Some of them is like news commentary and stuff like that. So if you like my content, I have one ask for you: destroy that like button for me. It really, really helps. And subscribe to my channel if you haven't done so, and also leave me a comment here. But now, let me take a moment here to have a quick peek at my live chat here. Yeah, Solana is now Agave. I've had to compile it, so I have some experience. Oh, that's great. You've already compiled it. How to compile it on ARM64 Linux. That's great to hear. And now here's a question, live question coming in. To run Xandeum Agave on Solana testnet, I would need a server. What specs do I need? There is a Solana page for that, right? Just Google Solana testnet requirements and you'll find it. Solana Foundation has published that. I think it should have at least 128 gigs of RAM or something. You know, the RAM is mostly the critical thing, right? If you rent it in a data center, the RAM is mostly the cost determining factor, right? And you know, many VMs, they just only go up to like 16 gigabyte or something for these smaller use cases. Yeah, okay. Tmux VI is an IADE, my man. Bernie's my man. Yeah, I'm that guy. I don't know, right? And you know, it's easy to show also in a video here, but we're using a lot of Visual Studio Code, VSC, here in the company as well, and much of the team, and I do it sometimes as well, but sometimes, I don't know, just VI and Tmux is my thing. All right. Okay. Yeah, absolutely. HJKL keys, yeah, I'll do that most of the time as well. Good. Yeah, so this was my sneak peek, a little bit of an insight on what we're building here, how we're building it, so that you get a little bit of a feel for where we're at, what you will be running on the Devnet if you decide to run a node on the Devnet. The Devnet validator nodes will be, you know, the goal is they will be live this year. It's a little bit tough to get it in the last few days of the year, but I think we can do it. DAO proposal that's coming out, it's incentivized, so you will get incentivized with locked XAND tokens as we had before, and we're going into that new DevNet. We want to have that up, and then, you know, during the next few weeks, we will have some new versions with the dock up there, with the XAND miner integrated, with some rudimentary prototype, right? Don't expect too much, because we want to have the DevNet up also with the PNodes in order to do that rapid development cycle and to be able to test everything out on the DevNet then. And we also have our Trinet here, so I can deploy to my Trinet. You know, we can compile the whole validator in 5 minutes and then deploy it into our Trinet, which is a 3 node cluster, right? But it's not Trinet with an I, which would mean like 3 clusters. That would also be a good name, but we called it Triname with a Y because we can try out things there easily, and we can deploy it in 30 seconds, right? So we build, boom, we make a change to the validator code, build it in 5 minutes, deploy it to Trinet in 30 seconds, right? And test out things there. And once we have some state where we think, now we want to test it on the DevNet, because the DevNet is a way more closer to production environment. That's why we need that DevNet. We don't want to test everything just on our 3 node cluster, and then maybe we might add like 5 or 10 PNodes or something. That's something for internal rapid prototyping. But, you know, in some cycle, it might be a week or so. We just push these releases out to the DevNet, to test it out in a real live environment, to test it out with operators that are from our community, right? Not only ourselves as operators. And that just increases the quality of the software that we're building. And yeah, I hope that gave you a little bit of an insight. I bet you have a lot of questions, right? Because we could only scratch on the surface today of what we're doing here. So please take the time to leave me a comment right here in this YouTube video and ask me any questions you might have, or just give your general comments. But think a little bit about something that is your opinion, your personal opinion, right? Not just, hey, it's great or something, but something that relates to what you have experienced or what your personal opinion is, so that we can engage with others here in the comments right in this channel, because that's what these comments are for here in YouTube. It helps you guys connect with other people like you that want to know how should we interpret this, how should we interpret that, or if you have questions for me, do it right here in the YouTube comments. I would really appreciate it. For today, though, I hope this gave you a little bit of the sneak peek that I promised in the title of the video. And yeah, thanks for watching, guys. Catch you later.